Let's now consider how we solve this question using the Lambert W formula. Okay, it's actually a formula that we can use to solve this kind of equations algebraically. Now, Lambert's W formula, what does it state? How does it concern this question? And what do we mean when we say Lambert's W formula? Okay, so Lambert's W formula simply means if I have an expression like x e to the power of x to be equal to y. This is just the easiest method for you to understand this. Lambert's W formula simply means when I see this, I should take the W, which is basically Lambert's W formula, but the W simply means the product log. Product log. That's what W means. So you should take the W of both sides. Now, let's take the W of both sides. Let me show you something. So we have W x e to the power of x to be equal to W of y. Now, W of this always is x, and this is what W of y. And then there is a calculator. I don't know if you've heard of it. It's known as the WOW RAM Alpha. Okay, this is the name of a computer. A calculator is compute stuff that can calculate this for you. So you just type in product log of whatever number you want to type in. So this W simply stands for product log. Type in product log of 20, for example. It gives you the answer. That's how this whole Lambert's W formula thing came about. But then what I want to emphasize on is this: you must have an expression in this format. So the expression must be in the format of x e to the power of x. Okay, so if you can get expressions to this formula, then it will be easy to eliminate this to get only this. Okay, so now let me just go in details on how we actually apply this. So let's apply it in this question we have, for example. So we have 2 raised to power x is equal to 4x. And as I said earlier, we are going to be making use of the Lambert W formula. Now, first thing to do is to get this thing looking like this. Now, let me keep 4 one side, or let me keep 1 over 4 one side. So I have 1 over 4 is equal to x, right, over 2 to the power of x. Does it make sense? Because I can divide both sides by this and divide both sides by this. Now, I still have that 1 over 4 again becomes equal to x over 2 raised to power x times as x times 2 to the power of negative x. Okay, so I've literally collected my s to one side. But then look, here we are required to get this in the form of x e to the power of x. But then here we have x2 to the power of negative x. So we're going to look for a way to replace this. Okay, this 2 here with e. Now, where does e come from? Now let me show you a bit of fun something. Remember, you have something known as natural log. You usually see something like ln. That's natural log. Natural log is simply log 2 base e of any number. Okay, so if you're going to go by this, now let me show you how we can easily replace this with this. So if you, for example, we have a number 2. So we say a natural log of 2, for example, is equal to y. Okay, now remember from your indices that e raised to power y invariably becomes equal to 2, right? So e raised to power y will become equal to 2. But then there is something that is very interesting that I'm going to do here. Let me bring back what y is here. So that e raised to power y becomes equal to log in base e of 2, and this is equal to 2. So it means that e raised to power log in base e of anything is equal to that thing. Now, if I do it here, I have that this thing now becomes equal to e raised to power log in base e of this man here, and it's equal to this man. Okay, so I don't need to touch this and touch this. So what I also have is that 1 over 4 is equal to x times e raised to power. Now, log in base e of 2 is something as natural log, that's ln of 2. So I can easily replace this with ln of 2, okay, all raised to the power of negative x. Now, this is another place I do something interesting. Now, remember from your indices that when you have something like log in base 3 of 5 raised to power 2, you can write this as 2 times log in base 3 of 5. So I can go ahead and do it here again. I have that 1 over 4 is equal to x, this now is times e, okay? Now this is now minus x natural log of 2, just like this. Now this is now where we start seeing the answer a bit. You have negative x and you lane 2, and you have here positive x only. And recall that if we want to apply this our W formula, we need the same thing here and here. Okay, good, but we don't actually have the same thing here and here. So how in the hell are we going to end up getting something that is similar here and here? Let's multiply both sides by negative lane 2. Can we do that? Since this is an equation, we can do it. So we multiply this side by negative lane 2. Multiply this side by negative lane 2. So that you now have what? Negative lane 2 over 4 is equal to negative x lane 2 e to the power of negative x lane 2. Ho, what have we done here? What have we done here? This is crazy. We've actually gotten the same thing here and the same thing here. Now, can you now agree with me that this equation has gotten to the beautiful spot where we can easily apply our W? Okay, because we need something in the form of W into x e to the power of x, and now we've gotten something here and here. So if you can see, now let's apply our W and we are done. So we apply our W to this side. Okay, so this is beautiful, and apply our W again to this side. And I told you that W of x times e to the power of x is the same thing as x. So what's this whole man here? It stands for our x here. So this W now becomes equal to negative x lane 2. And what is this equal to? W of negative lane 2 over 4. Hence, what does x become equal to? X now invariably becomes equal to W of negative lane 2 over 4 divided by negative lane 2. So basically, what this means is if we go to our Wolfram alpha calculator and impute this beautiful expression here, we'll get the value for x. And this is about, I don't know, just if you go to your Wolfram alpha and impute this, you get whatever you want to get. But imputing this first product log of this expression here, that's lane 2 over 4, and divide your answer by lane 2 negatives, and you get whatever the answer to this expression is.